Okay, morning everyone. Welcome to this session number 507. And today I will continue with this problem is the LRU cache, an algorithm that helps us to handle the cache. And in this case, as a summary of this problem, is explain this algorithm. The idea is that every time where, yeah, the last element in the cache that has the last iteration is the more recently element. Yeah. And this is the idea. Now, yesterday I was doing this. Basically, I create a class named node that have reference to the previous and to the next because the idea is solve this problem or perform these operations to get the put in constant time. And I think that I will get this using the linked list. Well, in this case, a double linked list. And at the beginning for the constructor is only receive the capacity, set this capacity and initialize the pointers, yeah, and the linked list. Now, the next is, okay, the get, I receive the key. I ask if this key exists. In the case that doesn't exist, return S1, that is the default. In other case, in essential is that I am getting the node that is saving in the map by king, yeah, and I get, and it in essentially is disconnect to the current elements and reconnect on the final. Yeah, and here for the put is the same. Where exists, the first is validate. Okay, aha, for example, the first time, if you had two slots and it's the first time that you are using this put, in this case, size is equal to, now exists, in this case, no. Okay, you need connect and do this operation. In the case that exists, in essentially is get, no, sorry. This is the case where exists and where is new, basically is create, connect with the final and do these operations. Okay, now, what is this case? Okay. We have all slots full. I need remove from the node after. Okay. Yeah. In this case, I have left. Mm, left dot next equal left dot next dot next. Yeah. Ah, now right I'll be back. Okay, now in this case, for example, where you imagine that I have only two slots, yeah, and in this moment, for example, have these values, and now I need to put a new one that is this. And essentially, is that disconnect this, and now after this number two, I need to put the nine, yeah, and this in essentially is with this right dot next, it's equal node and in this case the previous is right, the next is null, and the value is this. uh, Math.put this is e and is mm, ah, I need to no. Here I am null different thing is right, right is soon in variable uh-huh. Current Vector. Okay, no, this is wrong. Here I don't need return same. Uh, and here I need that this is one here uh, oof, have two slots. The first is this two one two one one. Now okay, now in this case this is the this yeah is the one. Now prep is two and one. The prep is the two. In in this case the prep is the two. The next the one. No, the prep is the two. The next is null. Yeah, because the next after this is null. Prep dot next is equal dot next. This dot next is equal this. Now next that is null dot prep is equal prep. This moment I will get new this one two. Okay, now I have two and three. This 3. The prep is null. No, is the dummy pointer. The next the 3. Mm, 1. The 3 reach the last. This is done. Okay. In this case is the error. First time is a 2, but the 2 doesn't exist. Now 1, now 2. Now the 1 is front. Now it's 3. Now it's 2, but doesn't exist. Now 4. Now it's the 1, but doesn't exist. Now the 3. I think that I can detect if currently this node is in the front on the list, and where happened this, and essentially is only ignore. If right dot equals n, return n dot value stop. It's because the next, yeah, works, but where is the last element? But for example, if I have 1 and 2 and the size is 2 and now the new element is, for example, 10, the 1 disappear and now the 10 should be appear at the front. Uh, but next it's equal null because yeah, I think I need validate this. One, three, four. Okay, I am doing incorrect with the what is happening. Two, it doesn't exist now. One, now is two, now is one, now is three. Okay, it's where I put new element, but the size full. Now I am saying left dot next is equal left dot next dot next. I'm connecting the left with uh, 1 and 2. I am disconnect the okay. Dot prev equal left. prep it's left, left. Okay, I think that I need save this. Now x equal x. Now prep equal because here, for example, I have one, and now it's connected with two. Now the one is in front, and for this now is the three. Okay, that this should be disappear, and so where is this? I am getting the left dot next dot next is this. I am connecting the left dot next is equal to this. Now x that is this dot pref equal to this. So, you know the pref, the right, and now right dot next is this. Next is null. With the get. The tree doesn't exist. Is for this. This is one and one. That is this. Two. Now is the one. Now three. For example, in this case, the key, the size will be is one in this. It's here. Now left dot next dot next. That in this case is the two. Now is left dot next. It's equal to. Basically, no. Now I have connecting the to me node with the number one. Yeah, and I disconnect the number two. Now x that is the number one dot pref it's equal left. I am connect the two the one with the dummy pointer. And now I create a new saying that the previous is the right is for this. Right is equal right dot next. I think that is wrong, right? With ph. Sorry. Next. Okay, let me following the process. Sorry. Where I am here. Okay, it's the first time. It's the one case save doesn't exist means that I should be executing code. Uh-huh. Okay, the new one. Now the next is true. Case yeah. Is no here. Uh, get the one means that is get the uh, now is the three. Three is put exists. Right click here. Uh, uh-huh. I think that is for this because in any moment I am no, yeah, I am saving this. But what happened where the size, for example, is full but exists? I think that should be appear first the top and this inside them. Mm, yeah. Mm, yeah, the first is validate if this. Exists is in the case that no is if it is in the case that it's valid no done is that is used. No, I think that I will section, and I think that better if I only create one function that help me with this because it's a little confused. Private date front, yeah, where I receive the node L, node right, right, and new node. Potential, for example, the left, I know that the left is the dummy pointer, the right is the current last element, the least or the most frequent. case, for example, no, the first that is validate L equals right, quote means the first, this case, for example, where r equals is L dot next equal new node, right equal new node, right dot pref it's equal L dot next right. The first time right is right, but next is equal null. I think that this is not necessary because the first time is null itself. And here key. You know, and I need a counter as a global variable. This is global in this is this return stop. Now what happened where are not the same? I need to okay. Okay, here I think that I can put first, the first step is put the new node and the final, but the first is check if the right dot equals new node where the last element is equal the same new node, basically don't do anything. Yeah, stop. And in the case that is not the last, is right dot next equal new node. New node dot pref equal right dot next, no, right it's equal right dot next, and now here so cool is that I remove the first case is counter minor at 0. It's minor 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 equal. In this case I need to say left equal left dot next, yeah, and left dot next dot pref equal left. Mm, oh, where is the last element? Okay, I think size. Oh, here, this is where the element exists. Map. Okay, if exists, mm, this is not that is here. Sorry. Now here, because I only reduce if it doesn't exist. Okay, yeah, sure. And here, map dot move. I need to remove this. No, 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 but here. L, I will check. This is the first time. Okay. Now the next that is for check if the front is the same that this element basically don't do anything. In the case that it's not the front, okay, node, we remove. Okay, and now here that is node m equal in the default node null null value is L left right and the key. It is none. No, wait. It's not counted, it's size. Oh, mm, I don't know. I think that I am losing the reference, but I'm sure that this is the right approach using the linked list. But well, I think that it's enough for today. Thanks for following this transmission, and I